I'm Ethan Odell, and today I'll be giving my presentation on the Module 6 assessment for Engineering Econ. So the agenda for this PowerPoint, I'm going to go over the background of the project that I'll be working on, the given information and statistics that were given, the cost per year calculations, and the cost per pound of steam calculations for oil, gas, and the coal. Then we're going to evaluate the materials and see which ones we should select for our final fuel option, and then we're going to have a conclusion as well. So the background, I'm a mechanical engineer working for a large electric company, and my job is to evaluate the equipment, the labor, and the materials to improve the efficiency of the plant. In this project, my job is to evaluate the fuel source going into a boiler, and we have to have the most efficient heating source and the most also cost-effective source to save the company time and money. Emissions and the power needs from the surrounding community also need to be taken into effect while working in this project. Some other background, some other considerations, the construction of the equipment, the salvage value of the equipment, and the labor are all tied into the cost evaluations. The two options are coal and gas/oil. Oil and gas must have a switchover equipment setup because the surrounding community depends highly on gas and oil for their power supply. On the pie chart over there, we can see that this is the fuel consumption for the United States in 2020. You can see the natural gas and petroleum take up over about 70% of the consumption, and then coal is only 9.9%. And then this chart right here is the global CO2 emissions from fossil fuels from 2018. And we can see that coal emissions are much higher than gas, and oil still is not even emitting as much CO2 as coal is. So this is some given information. I'm not going to read through all this, but some of the given information is coal. It gives the cost to build the operation, and then also requires an electrostatic precipitator to reduce emissions. So we must add that into the cost to construct the coal operation. And then it gives the current cost of coal per metric ton, the cost to build the gas and oil switch-off setup, the current cost of gas, and the current cost of coal. And the salvage value of our equipment will be $1,000 for each one. We are also looking to have an output of steam of 145 million pounds per year. The interest rate on the equipment is 10%, and we're looking into a time span of about 20 years. And then here are some efficiencies of the operations with also some conversions as well. Okay, so here is the cost per year calculations. On the far left there, we're looking at the cost per year for coal. Now we're given that it's $125 per ton of coal, and we're going to convert that to pounds so we can then convert that into BTUs. And then we know that we must operate and make 145 million BTUs of steam per year. Sorry, 145 times 10 to the 9th BTUs of steam per year. So we must multiply our equation by that. The 1 over 0.75 is our efficiency of this process, and then we multiply it by 1 because the coal operation does not require a switch off, and it will be operating all the time, 100% of the time. And we get a value of $766,000 per year. Now we go up to the cost per year of oil, and we get that oil is $2.93 per gallon, and we convert that into BTUs, and then multiply that by the required amount of steam, by the efficiency, and this operation was given that it was only going to be running 6% of the time, so we multiply it by 0.06, and we get $225,000 per year. The The cost per year for gas, we're given that it's $14.50 per MCF, and we convert that into BTUs, multiply it by our steam required output, and multiply the efficiency, and this process will be running about 94% of the time, so we get about $2.5 million per year. Now we're looking at the cost per pound of steam, but first we're going to look at the cost to build each setup. For coal, it costs $2.5 million to build, and then we have to also add the electrostatic precipitator as well, and then we can subtract the salvage value from this cost of building, and we get about $2.7 million. And then we're looking at the cost per pound of steam. How much is it going to cost to create 1 pound of steam through this process? And given the interest is 10% and our time is 20 years, we can get a capital recovery factor for our equipment of 0.1175. And here we can then multiply that by the cost of building, add that to the cost of operation that we got earlier in the last slide, and then divide it by the total pounds of steam we must create per year. And we get the value of coal per pound of steam to be $0.0075 worth. And then we look at the cost to build the gas and oil operation, and we can subtract that. We can subtract the salvage value from that and get about $1.2 million. Then we're going to use our capital recovery factor as well and multiply our cost of building by that, and then add the cost of the operation of the coal plus the operation of the gas as well. Those are those two values right there, and divide it by our total pounds of steam per year, and we get that this operation would cost 2 cents per pound of steam. So now we're going to evaluate the two different options that we have. Coal, we have the total cost of about $1 million per year for this operation, and gas and oil is about $2.9 million per year. The cost per steam and coal is much lower than the gas and oil operation, and this means that the coal operation is more efficient, cost efficient than the gas and oil operation. So in conclusion, I suggest that we use coal for this project. Emissions might be a concern, but due to the electrostatic precipitator, I believe that emissions can be reduced much lower, and I also think that we can add different equipment with the money that we've saved using this option to also reduce more emissions. Our total savings per year by choosing this option would be $1.8 million, and this also has no effect on the power of the homes and the manufacturing plants around it, because they all require gas and oil. And yeah, I just believe that the coal fuel supply is the best option for this project, and it should serve our plant and our company much better in the future. Thank you.